According to every model we have of how planets form, how solar systems are built, how gravity and physics behave over billions of years, Mercury should not exist in the form it does today. And the closer we look, the less sense it makes. Every answer we find opens 3 new questions. Every mission we send back comes with data that breaks the models we spent decades building. Mercury is not just strange. It is the kind of strange that keeps planetary scientists awake at night, staring at numbers that refuse to add up. This is the story of the most mysterious planet in our solar system. Let's begin with what Mercury looks like from the outside. It is small, the smallest planet in the solar system, roughly the size of our moon, scarred with craters, gray and barren, orbiting the sun so closely that a year on Mercury lasts just 88 Earth days. At first glance, it looks like the least interesting object in the solar system. That first glance is completely wrong, because beneath that gray, cratered surface lies something that violates everything we understand about planetary formation. Something that has no business being there. Something that, by every rule of physics, should have disappeared billions of years ago. Mercury has an enormous iron core. Not just large, not just significant, enormous. Mercury's core takes up approximately 85% of the planet's entire diameter. To put that in perspective, Earth's core makes up roughly 50% of our diameter. Mars is even smaller proportionally. Mercury is essentially a giant iron ball wrapped in a thin shell of rock. And that is a problem. A serious, fundamental, paradigm-breaking problem. Here is why it matters. When planets form, they follow rules. A cloud of gas and dust collapses under gravity. Heavy elements like iron sink to the center. Lighter rocky material forms the mantle and crust around the outside. The closer a planet is to its star, the smaller and rockier it tends to be, because intense solar heat blows away lighter gases and leaves behind mostly rock. By every calculation, Mercury should have a modest iron core surrounded by a thick, rocky mantle. Similar proportions to Venus or Earth, just smaller overall. Instead, Mercury has almost no mantle at all. The rocky outer shell is only a few hundred kilometers thick. Beneath it, almost immediately, you hit iron. Dense, heavy, dominant iron stretching almost all the way to the surface. Something stripped Mercury's mantle away, violently, completely, and then disappeared without leaving a single trace behind. The leading theory is a collision. Early in the solar system's history, something enormous, an object potentially as large as the planet itself, struck Mercury at catastrophic speed. The impact was so violent, it did not just damage the surface. It vaporized the mantle, tore it away, hurled it into space or directly into the sun, leaving behind a naked, exposed core wrapped in almost nothing. But here is where the story turns dark. If that collision was powerful enough to strip almost the entire mantle off a planet, it should have also destroyed the core, shattered it, scattered it across the inner solar system. The energy required to remove that much material should have been incompatible with Mercury surviving as a coherent object at all. And yet, here it is, still orbiting, still intact, still defying explanation. The physics of the collision theory does not fully work, not cleanly, not satisfyingly, which means either our models of planetary impacts are catastrophically wrong, or something else happened to Mercury entirely, something we have not yet imagined. But the core is not the only thing wrong with Mercury. It is still alive. For decades, scientists assumed Mercury was geologically dead, a cold, frozen, ancient world with no internal activity, no volcanism, no movement whatsoever. Just a scarred relic sitting close to the sun, slowly being baked into nothing. Then we actually looked. When the Messenger spacecraft entered orbit around Mercury in 2011, the first spacecraft ever to do so, it began sending back images that changed everything we thought we knew. Mercury's surface is covered in long, winding cliffs called lobate scarps. Some of them stretch for hundreds of kilometers, rising over a kilometer high. They cut across craters, across plains, across ancient terrain without mercy or pattern. These are not impact features. They are not old volcanic formations frozen in time. They are the surface of Mercury wrinkling and buckling as the planet continues to shrink. Just like a grape drying into a raisin, Mercury's core is cooling, contracting. And as the interior pulls inward, the outer rocky shell has nowhere to go. It compresses, it folds. It creates these enormous cliffs that crawl across the surface like scars on something still healing. Mercury has shrunk by up to 7 kilometers in radius since it formed. 7 kilometers. A planet physically getting smaller, and based on the geological freshness of some of these scarps, the process is not finished. It is happening right now on timescales that overlap with the existence of our own civilization. A planet we wrote off as a dead rock is quietly, relentlessly reshaping itself in the dark. Now, here is something that should genuinely stop you. Mercury has a magnetic field. This sounds unremarkable. It is not. A planetary magnetic field requires a liquid, electrically conducting layer deep inside the planet, typically a molten outer core, rotating and convecting in a way that generates sustained electric currents. Earth has this. It is what creates our magnetosphere, the invisible shield that deflects the solar wind and makes life on the surface possible. But Mercury is tiny. Its core should have cooled and solidified billions of years ago. A planet that small, that close to the sun, with that much surface area relative to its volume, cannot possibly retain enough internal heat to keep any portion of its interior molten. The numbers are not close. They are not even in the same ballpark. By every calculation we have, Mercury's magnetic field should not exist. And yet, Messenger measured it, clearly, precisely, unambiguously. A magnetic field roughly 1% the strength of Earth's, weak but real, present. Not a fossil remnant locked in ancient rock, an actively generated field produced by something moving and churning inside the planet right now. The leading hypothesis is that Mercury's enormous iron core contains unusual elements, perhaps sulfur, perhaps silicon, that dramatically lower iron's melting point, keeping the outer core liquid far longer than physics would normally allow. But this hypothesis has not been proven. It has not been directly confirmed. It is our best guess dressed up in scientific language. The honest answer is simpler and more uncomfortable. We do not know why Mercury has a magnetic field. We do not know what is keeping part of its core liquid. We do not know how a planet this small is still generating something this significant. The more instruments we point at Mercury, the more questions come back. And then there is the orbit. Mercury's path around the Sun is one of the most extreme ellipses in the solar system. At its closest approach, it is only 46 million kilometers from the Sun. At its farthest, nearly 70 million. This wild swing in distance creates surface temperatures that vary by over 600 degrees Celsius between noon and midnight. But it is not the shape of the orbit that matters most. It is what the orbit does over time. Every time Mercury completes one full journey around the Sun, the point of its closest approach shifts slightly forward. The entire orbit rotates, slowly and continuously, like the petals of a flower turning in slow motion. In astronomy, this is called orbital precession. For over a century, this precession was one of the most embarrassing unsolved problems in science. Astronomers could calculate it, they could measure it precisely, but when they applied Newton's laws, the same laws that predicted the motions of every other planet with perfect accuracy, the numbers did not match. Mercury was precessing faster than it should. Not by much, but by an amount that was real, measurable, and completely unexplained. Some scientists proposed a hidden planet between Mercury and the Sun, a ghost world they named Vulcan, whose gravity might account for the discrepancy. Astronomers searched for it for decades. It was never found, because it does not exist. The answer, when it finally came, did not come from astronomy at all. It came from Albert Einstein. In 1915, Einstein published his general theory of relativity, a complete reimagining of gravity not as a force, but as the curvature of space-time itself. Massive objects like the Sun do not simply pull on nearby objects. They warp the geometry of space and time around them. And Mercury, orbiting so closely, moves through that warped geometry in a way that Newtonian physics simply cannot describe. When Einstein calculated Mercury's orbital precession using general relativity, the numbers matched perfectly. Bepi Colombo, a joint mission from the European Space Agency and JAXA, is closing in on Mercury right now, expected to enter full orbit in late 2026. It carries instruments more sensitive than anything Messenger had. When it arrives, it will probe the magnetic field in 3 dimensions, map the surface chemistry in extraordinary detail, and attempt to finally answer the question of what is keeping that core liquid. Whatever it finds will matter, not just for Mercury, for everything we think we know about how planets work, how solar systems form, and how deep the gaps in our understanding actually go.